Okay, this is the algebra review sheet. We will work all of these problems out by hand, showing the traditional algebraic solution methods. Let's consider number 1. The area of a pie is square root 72. If the pie is cut into 6 equal slices, what is the area of one slice? It says in parentheses, no decimals. You must write your answer using whole numbers and radical notation. What that means is the calculator can't really help us here. So let's take what we're given. We're given the square root of 72. And we're told that this is the area. Because it's a pie, we know we're dealing with a circle. So we need the formula for the area of a circle. The area of a circle is equal to pi times the radius squared. So that's what square root of 72 is. It's pi times the radius squared. We don't need this formula for what we're going to do with this problem. But it's good to know that formula because it's something we don't review a lot in Algebra 1. So if the area of the entire pie is the square root of 72, the area of one slice is equal to the square root of 72 divided by 6. So I've got to break down, in order to write this in the most simplified notation possible, I have to break down the square root of 72 and see if I can't simplify that square root. So in order to do that, we have to prime factor 72. So we'll do that right over here. We'll take 72 and we'll start to prime factor 72. You want to start with the lowest possible prime number that you can think of that will divide evenly into 72. And that number is 2, because 72 is an even number. So 72 divided by 2 is 36. So next to the 2, put a 36. And we can break down the 36. Again, we want to think strategically here and use the lowest prime number we can think of. For 36, that would be 2. And 2 times 18 equals 36. Okay, so now I want to break down 18. Again, the lowest prime number I can think of that will divide evenly into 18 is 2. And 2 times 9 is 18. And now, because 9 is not yet prime, I have to break 9 down into its prime constituent numbers. And those are both 3s. 3 times 3. The goal of doing this is that we find all the primes, which is what we just did. So now we must rewrite what we have. Okay, so again, the area of one slice, this is one slice now, is the square root of 72 over 6. But instead of writing the square root of 72, we will write, here, let's write this again just so we keep clear what exactly we're doing. The area of one slice is equal to the square root, and you want to make this square root longer so you can fit all those prime numbers underneath it. Two times 2 times 2 times 3 times 3 equals 72. So we can replace that 72 underneath this symbol here, which is called the radical symbol. We can replace that 72 with 3 2's and 2 3's. 2 times 2 times 2 times 3 times 3. Okay? Now, we're taking the square root, and that means the index number, that's the number that's nestled right here, is actually a 2, right? With square roots, we don't put that 2, it's just assumed. But there's really a 2 there, so if I'm simplifying this square root, what I can do is search inside my prime factors for any pair of 2 numbers that are identical to one another, because 2 times 2 is 2 squared. So if I take the square root of 2 squared, I can actually pull that part of 72. I can break it down into prime numbers and then pull part of it outside the square root symbol. So we want to circle any sets of 2 numbers. So I've got 2 2's, and over here I see I've got 2 3's. And the way that works, let me finish writing this so we don't lose track. All of that will be divided by 6 when we're done. So now we've got to think, what do I do with this? Well, if I can find 2 numbers that are the same, 2 times 2, that's 2 squared, take the square root of 2 squared, and they kind of come outside of the radical, like this. Same thing with those 2 3's. They're going to come outside of the radical. So we'll put equals sign and continue with our math. On the top, I will pull a 2 out times, and then I'll pull the 3 out, 3. And what that has the effect of doing is it cancels them on the inside of the square root, like that. So then I put the square root symbol, and I write whatever is left that was not circled. And that's just that one solitary 2 right there. So now I have 2 times 3 times the square root of 2. This still equals the square root of 72. Over 6. Don't want to lose track of that 6. Because remember, we're trying to find the area of one slice of pie. So continuing on, 2 times 3 is 6 times the square root of 2. And all of that is divided by 6. And now continuing on, we can cancel the 6's, leaving behind the square root of 2. So that is the area of one slice of pie. Number 2, what are the combined areas? Okay, so what we should do here is find the area of this rectangle, and then find the area of this rectangle, and then add them. Okay? Okay, so we'll take this one first. We'll find the area. Now, the way we do that, area is length times width. So it's be useful to remember. Area of a rectangle is equal to the length times the width. And so we'll take this first figure here, and it's 4x times 2x minus 1. So we write it like this. We'll call this shape 1, and we'll call this shape 2, just to keep them together. So now this is the area of shape 1, just so we're clear about what I'm working on right at this moment. The area of shape 1 is equal to 4x times, just put an open parentheses, 2x minus 1, close parentheses. And now we distribute the 4x inside the parentheses. So 4x times 2x equals 8x squared. So this is 8x squared. And 4x times negative 1 is negative 4x. Okay, that's the area of shape 1. Go over, well, I'll continue doing, I'm not sure where I want to do the work. I guess I'll do it here. Over here, we'll do the area of shape 2. Okay, we'll do that right here. The area of shape 2 is 3x squared plus 4x plus 6, and then we want to multiply that, so put it in parentheses, and next to it, put an open parentheses and put the width, which is 2x plus 3, close parentheses. And now it's a matter of how do we multiply these two things together. There are multiple ways of doing this. The easiest way I've always found is to use a box. So I need a box that's long enough to accommodate these three components on top, and then wide enough to accommodate these two components. So this is a trinomial multiplied by a binomial. Trinomial because here's a term, here's a term, here's a term. Binomial, so there's 3. Binomial because here's a term and here's a term, that's 2. So trinomial by a binomial means I need a 2-row by 3-column table if I'm going to use the table method. So just make a little table here that has space for 3 columns and 2 rows. Up on top, I will write 3x squared, and then I'll put plus 4x, and finally over here, plus 6. On the rows, I will take this 2x and I'll put it on the top row, 2x, and then I'll put here plus 3. And now what we do is we multiply the row by the column and fill in these boxes. So the top left would be 2x times 3x squared. We have to use our understanding of the rules of exponents and remember that 2x is really 2x raised to the first power. And the product rule of exponents is that when you multiply 2 exponents together with the same base, in this case the same base is x, you add their exponents. So the 2 and the 3, those are called coefficients. We're first going to multiply the coefficients together. 2 times 3 is 6, so we put a 6. And then x to the first times x to the second is x to the 1 plus 2, or x cubed, x to the third power, x cubed, right in there. Okay, you can fill this out in any order you want, but I typically go down. Now I have 3 times 3x squared. So I only need to multiply 3 times 3, which is 9, and then just write x squared. It comes along for the ride. Okay. Now we'll move on to this cell right here. I have 2x times 4x. So again, multiply the coefficients, write the base, which is x, and then add those exponents. And this also has a little 1. So I'm going to end up with 8x squared. 8x squared. And now I can fill this one in. 3 times 4x. 3 times 4 is 12. The x comes along, so I have 12x. The last column, 2x times 6 is 12x. And then I have 3 times 6, which is 18. And now we are going to write out all of this, and we're going to write it in order of the highest exponent. So first we'll do the 6x cubed, and then we'll write these squared terms, and we'll add them together, and then we'll write these ones where it's just x to the first power, and then finally we'll write the number that's just by itself. So I'm just going to write that out here very carefully. 6x cubed plus 9x squared plus 8x squared plus 12x plus 12x plus 18. Okay, and there are like terms that we can combine together. See, you're going to go by the base and its exponents. So these 2's, I can add 9x squared to 8x squared to get 17x squared, and I can add 12x plus 12x to get 24x. So we'll just kind of combine like terms, if you will, and write 6x cubed plus 9 plus 8 is 17. 17x squared plus 12 plus 12, 12x plus 12x is 24x, and then just plus 18. So that is the area of shape 2. It took a little bit of figuring, but nothing horrible. And now it's time to, it says what are the combined areas? Okay, so combine means add. So we're going to add the areas together. So we want to take the area with the most terms, okay, and write it out. And then beneath it, we will stack add the area that has fewer terms, and we will place very strategically the terms with their proper exponent. So I'm going to line them up in a specific way. So let me just write this really quickly. I'm going to write this area first. 6x cubed plus 17x squared plus 24x plus 18. And underneath it, I'll write 8x squared minus 4x. But I don't want to start all the way to the left. I want to start here because there's an x squared. So underneath it, I will put 8x squared, and I have minus 4x. So I'll put the minus 4x underneath the x term. So then put a line. It's basically like an addition problem. Put a plus sign right here. And we can add from left to right. So I have nothing underneath the cubed, so I can just bring that down and write 6x cubed. And now I have to add 17x squared to 8x squared. Because they have the same base and exponent, I can just add the coefficients, 17 plus 8. So if 7 plus 8 is 15, 17 plus 8 is 25. So it's 6x cubed plus 25x squared. Now, got to be careful here because I've got a negative term. I have 24x plus negative 4x. So that's like saying 24x minus 4x. So we just subtract, basically I'm subtracting now 4 from 24. So I have plus 20x. And then the 18 is alone, so it just comes down plus 18. And that is the combined area. This is the combined area of shape 1 and shape 2. Okay, and you can kind of use the addition line that you drew to make like a box. Okay, just put it in a box. There it is. Okay, number 3, solve this, and we want to use the completing the square method. All right, it's 2x squared plus 8x plus 2 equals 0. There are other ways that you could solve this, but we will solve it by using the completing the square method because we need to practice that skill. And we'll see where it takes us. The very first thing I need to do is divide out this 2. Okay, because I cannot begin completing the square until I have a leading coefficient of 1. So let me show that. Write this quadratic equation again. 2x squared plus 8x plus 2 equals 0. And now to get rid of the leading coefficient of 2, we will divide each term by 2. Okay, so including the leading coefficient. So I'll divide the 2 by 2, the 8 by 2, and then that final 2 by 2. And then even on the other side, I've got to divide the 0 by 2. It won't mean anything, but you still have to do it. So divide 2, 2, 2, 2. Okay, and the benefit there is we got to cancel those 2's. Now I just have x squared plus 4. 8 divided by 2 is 4x. And then 2 divided by 2 is 1 plus 1 equals 0 divided by 2 is 0. Right? So here is our simplified quadratic equation. And we can begin to do completing the square. The first step in completing the square is to subtract this final term here that's by itself. This is called a constant because it's by itself. It doesn't have an x, so we're going to subtract it from both sides. Right? And then we'll rewrite x squared plus 4x equals negative 1. And now I want to represent these two terms right here with the shapes that I showed you. So x squared, you listen to the language, it's giving you a hint, means that you can kind of think of it as a literal square. Take some time in drawing it carefully and it will look like a square. And it's x squared because you have x times x. And inside it's x squared. See, x times x is x squared. And now we have this 4x term. And we just make a vaguely rectangular shape, but we need it to have the same height. Okay, so it's going to have a height of x and a length of, or a width of 4. And we just usually make a kind of arbitrary shape. We really don't know what the dimensions are here, but it doesn't matter as long as it doesn't look like a square. Okay, so we have here again x and 4. If you've ever played with algebra tiles, you see what I'm doing. Okay, as part of the completing the square routine, we're going to split this 4x term in half like that. So now I'll have each of these dimensions are 2, right? 2 and 2 make 4. And what you do in your mind is you kind of clip it in half with an imaginary pair of scissors, and you're going to take this little piece and put it down here. So it helps to, at this point, kind of redraw. Just this visual method makes more sense to me. It's not often taught this way, but it makes more sense. I never lose my bearings. Again, that's x times x. I'm just drawing this again. And this time, I'm going to draw just the little half piece, like this. Okay, and then down below that, I'll draw the other part of that rectangle right here. Okay, now those are supposed to be identical. Now they have x and 2 as their dimensions. X and 2. Okay, so what we're looking for is this little piece right here. This little square right there. What are its dimensions? Well, its dimensions are 2 and 2. So 2 and 2. Okay, so that is, all we need. So 2 times 2, the area of that little tiny square, that's what you completed the square. See, the area of that little tiny square is 4. And so what we're going to do is add that to both sides of the equation up here. So we just rewrite it. 8x, x squared plus 4x plus 4 equals -1 plus 4. Just like that. Okay. And now we can factor the left side of the equal sign. And that was the whole purpose of doing it this way. So we're going to quadratic factor. So if we just isolate the problem, all we're doing is quadratic factoring the left side right there. Just trying to show you that all you're doing is you're going to find two numbers that add to be the middle term and multiply to be the last term. So if you want to use the method that we've been learning, you can go up here, make some space. I wouldn't write down here, we're going to need this space. Go up here and say, well, I need two terms that add to give me the middle term, which is 4. And those same two terms need to multiply to give me the last term, which right there, just for that part, is 4. So what two numbers add to 4 and also multiply to 4. Well, those are 2 and 2. And if you're looking ahead to future problems, it's always going to be whatever half the middle term is. So it's 2 and 2. That's where those 2's come from. There they are. So we'll write the factored form of this little new quadratic that we created equal to -1 plus 4 is 3. I was starting to write a 5. So -1 plus 4 is 3. Okay, so here I'll put an x and an x. And now I have to put plus 2 and plus 2. And all that is, x plus 2 times x plus 2 is the factored form of this quadratic, x squared plus 4x plus 4. Now set that equal to 3. Okay, fair enough. This is where it is helpful to think of these factors as just units, okay? So this is identical. These two factors are exactly the same. So instead of writing x plus 2 times x plus 2, I could write open parentheses x plus 2 close parentheses and then put a little squared sign because x plus 2 times x plus 2 is x plus 2 squared. That's the idea. And so what we'll do next is write open parentheses x plus 2 squared. And all that I've done is I've represented the factored form of this quadratic, which is x plus 2 times x plus 2 as x plus 2 squared. And I'll set that, keep that set equal to 3. Now, whenever you want to get rid of a squared symbol, you use the square root. So we will take the square root, but just like any math problem, what we do to the left, we have to do to the right. So we take the square root on both sides. So I'm going to take the square root of x squared, x plus 2 squared, and then take the square root of 3. Just put those radical signs in there. All right, so when we take the square root of something that's squared, we just get rid of all of the stuff around it. And so I've got x plus 2 squared, and I'm taking the square root of that. So what that's going to leave behind is just x plus 2. Okay, all this stuff goes away, and that is equal to, when we take the square root of 3, we have to write plus or minus. And there's nothing we can factor out in terms of 3 because 3 is a prime number. So we just say x plus 2 equals plus or minus 3. And that's where the two solutions are going to come from here in a minute. So now I'm continuing to try to solve for x. And now I just subtract 2 from both sides. Okay, so I'll have minus 2 and minus 2. That gets rid of those 2's there. And I now have x by itself. X is equal to, we want to put that -2 up front. It doesn't matter. Just keep the signs together, whatever you do. I'm going to put -2 plus or minus. I see I dropped that square root symbol there. Sorry. It's the square root of 3. Plus or minus the square root of 3. Okay? And now we can actually find our two solutions. So I have x equals -2 plus or minus the square root of 3. So what that really means is that my two solutions are, I have x equals -2 plus the square root of 3, but I also have x is equal to -2 minus the square root of 3. Okay, so those are the two solutions to this quadratic equation. And there's nothing to simplify any further there.